Okay, hello again. So now it's the time to place more attractor points. Okay, not just one, but more of them here. Okay, so I'm gonna just I'm just gonna copy this guy two times. Okay, let's take this and let's move it somewhere in the middle. Let's move it, of course, also so that this one, let's say it would be like very low. Okay, and this guy will be really far away, like almost at the end of the surface. And let's put it quite low here, so yeah, somewhat something like this. Okay, and then what I need to do, of course, is to measure the distance from each single. So again, this is my list of centers of circles. These are my attractors, and of course I need to measure the distance from circles to each single attractor separately, right? So I have three different, 1, 2, and 3 lists of distances. Okay. Now, if I collect these distances, I use a node called create. Okay, I have this a list of three sublists of three branches, and now instead of having three with how many? With three with 292 elements, I want to have 291 branches with 3 elements each. In order to do that, I do transpose. Okay. Now I see transpose. Okay, and this means that for each single circle, okay, I see that the distance from this circle, which is the first on the list. If you look on which circle is the first, this one, right? So the distance from this circle to the first attractor point is equal 61. Okay, of course this circle will be attracted by this circle, by this point, by this sphere. The distance from this circle to this sphere is 582, and the distance from this circle to this sphere, this point, is 916. So it's of course that it's clear that this circle will be affected by this sphere and not by the other. Okay. Okay, so what I need to do now is to find which, because sometimes, of course, if you look on the second, whatever, let's look on some circle in the middle. Let's say this 159, circle number 159 will be, 159 will be here, right? And probably the closest sphere to this circle will be this one, right? Anyways, of course, that's not the purpose of making it. Dynamo allows you to make it, of course, automatically, right? First of all, I'm gonna also disconnect so it doesn't bake me all the time into Alias. Okay. So what I'm gonna do now is to find what is the lowest number on this list. It's not always only somewhere here. It's the first, right? Because it's the first sphere. Somewhere in the middle, probably it's already, it's, for example, on circle number 208, index 208, it's already the third circle is the closest. Okay, so I have to find out for which of these attractors, or which circles will be attracted by which attractors. Which circle will be attracted by which attractors. So you have a node called minimum item, okay? And it gives me, actually tells me, it looks inside the list. okay, and tells me, okay, 61, of course, 57, 60, and so on. And if I scroll down to the very end, of course, it gives me not 1,103, but 265, right? So I have the minimum item. Now, what I need to do is to find out, if I look at this list, of course, it's clear for me that 265, 59 is the second index, the third position on the last list. But I have to find it globally for the entire list. Now, I have a node called indices. All indices off. Okay. This will allow me basically to find, if I have a list, let's say, of, let me show you the example. If I list from 0 to 10, okay, list of numbers from 0 to 10, from 0 to 10. This is my list. If I ask him which index on my list has number 4, okay, he will tell me, okay, maybe let's make it more intuitive. Okay, from 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, number 4. So this element, don't look at the index yet. So this element has its position on the list as index number 3. Okay, I'm gonna do exactly the same here. I'm gonna use all indices off, but since we have a little bit more complicated situation, because we have I have shortest numbers, and I also have a list of sublists. Okay, I have branch tree and its branches, and I have to ask him to look inside each single branch, each single sublist, and to find out on which position I have the smaller number. So what you do, you need to find this node called list combine. Okay, and this is our list, and this is our minimum item. His run started. He's still it takes him, because he's to go through all the list, but we have a list of indices, and we see that first part of my list of circles will be, of course, affected by the first sphere with index 0. Some part of them in the middle will be affected by sphere number 1, index 1, and the rest will be affected by sphere index number 2, right? So I flatten this list, of course, because it's I have this a little bit uncomfortable superstructure structure. Okay, let me turn it off, and turn it off. Okay, and now, this will be a little bit maybe not complicated, but pretty funny what we're gonna do now. Okay, what I need to do is to find out, of course, which of these circles correspond to number 0. Okay, the best way to do that is actually to ask him. Okay, this is like another operator. Sorry. Okay, this is my operator, and I'm asking here, which from this list equals 0? And the answer will be like, true, 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 false, 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 the rest of the false. Okay, so what I'm gonna do, I will actually use now a node called mask. Okay, filter Boolean mask, to first to extract. So basically, you have filter by Boolean mask. You have two inputs. You have two inputs, right? Mask is always true, false, and then what I need to extract, of course, is actually, yeah, the numbers from which I'm using here. But here I have to do another again modification, because of course here these numbers are being calculated based on only one attractor. Okay, so of course here these are my distances. Okay, but these distances are regard exclusively this attractor. So what I need to use now, this remap range. For the moment, I'm gonna disconnect both elements, which make both inputs which create circles. So what I need to do is here I have my minimum items, right? So these are my new remap range. Okay, I'm gonna now filter these, and also I'm gonna filter my yeah, basically in order to, yeah, because I need of course the points. Okay, here are, look, here are only these which are close to this, and here everything rest. Okay, so but of course to avoid a copying and pasting this filter mask from filter by Boolean mask, I'm gonna take this and use it for only here, and look, you're gonna see some result already now, because of course these are points, these are numbers. So look, these are the replacement by condition, this is the circle. So what I'm gonna do is I'm gonna take, this is vector, so this is the normal, these are my numbers, and these are my points. Ha, you see? Why only these circles? Why not this, for example? Because he calculated that the distance between, for example, distance between sphere, this one, and this circle, which we'll see soon here, is bigger than distance from here to here. Okay? So the next step is, of course, so basically here with this, okay, so I'm gonna use this part of node of code, sorry, to here, sorry, and here. Okay, I'm gonna copy this. Okay, I'm gonna copy this, and I'm gonna use, and here of course I'm gonna change, because here I was searching for index 0, right, flatten, and here we're searching for which of them are 0, and now I'm gonna search for 1. Okay, immediately recognized it, right? Let me copy it again, and it's gonna be 2. Okay, perfect. So let me turn off the visibility of my points so they do not overlap, and it's a little bit so these are numbers. Okay, so I'm gonna turn off this and also this. Okay, and before moving these spheres, what I'm gonna do, I'm gonna flatten a little bit, because it's very steep, right, the parabola, right? So if I'm gonna decrease the parabola, for example, from the first, right, first attractor, then let's go back here and let's decrease a lot. Oh, you see? Now I can also decrease separately the range, like the range of how far this middle attractor affects the surrounding circles. Okay. And let's also see how it happens with the last one, with this one. So I'm gonna be a very small one like this. Oh, okay, and I see that, and of course only these circles will be affected, changed, those which have the radius lower than 7, right? Because here I have this basically this condition. Actually I should to use the same, because it cannot change, of course, because then I will not see this, let's say, nice smooth. So actually this should go from here to here, from here to here. Condition replacement, yeah. So I change it from one place. Condition and replace with, because now I can say, okay, if it's let's say, let's change it not from to 7 but from 7 to 6, right? Right. So basically, less circles will be affected, but 7 is okay, I think. Right. Okay, so we have it. Of course, we can go and bake it to Alias. I can, of course, I don't have to because I have 3 separate sets of circles. I can, of course, do it like something like join to avoid a situation which you have like 3 times baking to Alias. I can make it just once. One node which is baking to Alias, right? Here it is, right? And of course, if I start doing something here, like let me move one of these attractors, right? So let's move the one in the middle, right? So let's move it like a little bit below. Run started. Of course, he has to recalculate, rebake it to Alias. So sometimes it can take some time, but nevertheless. Now it moved. Yeah, now it's updated here. So it takes a couple of seconds to update, but nevertheless, it's. I think it's okay when it comes to quantity of time. Okay, so let me close this video at this point, and let's hear each other again in a couple of minutes in the next video.